Hello, everybody, and thank you for joining us. I'm Hormus Romer, and I will be your host today for this webinar. Before we get started, just a couple of quick housekeeping items. First of all, this webinar is being recorded, and you will have access to the recording later, which we will send you the information about. The webinar is meant to be interactive, so please feel free to ask your questions. There's a little button at the bottom right corner of your screen probably that says questions. You can submit your questions at any time. Please do so throughout the webinar. And we will be answering all of the questions at the end of the webinar. So with that, let's get going and let's introduce our speakers for today. I'd like to introduce Laura Case. Laura, if you could please introduce yourself.
Hi, my name is Laura Case. I'm a director of product management at Baffle. I have over 2 decades of experience in analytics, data warehousing, business intelligence. The name really changed over the last 20 years that I've been doing this. So I have experience working in different industries from financial services to insurance, and most recently in data governance. And so I'll turn it over to Sushant.
Hi, everyone, and thank you, Laura. My name is Sushant Rao. I run marketing at Baffle. I've been in the tech industry since, say, mid-1990s, starting at a little browser company named Netscape, really focused on the enterprise software and services side of the house. Worked on everything from data security to analytics and everything in between. So looking forward to this webinar and chatting with Laura about advanced encryption. So Laura, what are we going to cover in this webinar?
Yeah, so first we'd like to set the background and talk about data protection problems facing modern data teams. Then we'll talk about Baffle's advanced encryption for Postgres. And because the topic of data encryption and data protection is very technical, we'll walk through a data flow to understand how Baffle is able to support operations on encrypted data. So first, let's talk a little bit about the state of data protection. So as I mentioned, my emphasis in my career the last 2 decades has been in analytics and data warehousing. And when I started in the industry, traditional data teams had very simple data pipelines. You would have a few applications or data feeds all going into a common ETL tool, extract, transform, and load for those who are not familiar with that term. And then that would feed data into a central data warehouse. From that warehouse, you would send that data to a limited number of places. Maybe you had a reporting tool or some spreadsheets, maybe a couple of data feeds. Because the pipelines were simple, it was relatively easy to protect that data because there were very few places that data lived. Despite that, though, there weren't actually many regulations on how that data should be protected. And as a result, I saw a lot of data I should not have seen. One example that stands out to me is one of the first projects in my career, actually building a system for two-way pagers. So before cell phones had texting capabilities, and this probably ages me and maybe some people in the audience today, we actually had pagers where you could send what they called pages to each other. So you would have a pager, you would also have a cell phone, it just wasn't able to text. And so as we were building this system to test our data integrations, our customer would send us these enormous CSV files that had just pages and pages of these pages. So they would include their name, their phone number, their device details, and then these pages. And they ended up sending us a lot of sensitive data from all of their production systems, and none of it was protected. Our entire team of 20 plus developers had access to these files. So as I continued in my career, depending on the industry that I worked on, I would still have access to information like this as part of our normal development cycle. Now, fortunately, as our industry has matured, more privacy regulations around data have been implemented, and data teams are often responsible for ensuring data in their sources is protected wherever it goes. And again, going back to this diagram, this used to be a relatively simple system to protect.
So Laura, why are privacy regulations impacting data teams so much?
So This first point is very powerful to me. By the end of next year, 75% of the world's population will have its personal data protected by privacy regulations. To me, this is incredible because people have started to understand the importance of data privacy. I also want to point out that when we talk about protecting data, we mean one thing: encryption. These privacy regulations across the world that require protection of personally identifiable data require encryption to protect the data. So, however, despite compliance and privacy regulations increasing, including data residency requirements and compliance, on average, 55% of that regulated data in the cloud is not protected by encryption.
Laura, it sounds like compliance is saying that data needs to be encrypted. So why isn't it encrypted?
So the biggest barrier that data teams face in using encryption is the lack of ability to perform computations on encrypted data. So I'm just going to repeat that because it's a very important point to understand. Data teams lack the ability to perform computations on encrypted data. Simple encryption does not allow these types of operations. So even something as simple as sorting data is impossible while that data is encrypted, much less some of the more complex operations that data teams do when analyzing data. Here you can see some pretty simple examples: min, max, sort, search, averages. You simply cannot do that when data is encrypted. So this leaves data teams with very few options. They either need to have clear text access to the data, which increases the number of people in an organization with clear text, or they need to use what is called privacy enhanced technologies.
Laura, it sounds like there is a but coming.
Oh, Sushant, there's a really big but coming. there are technologies out there that can solve this problem, but there is another big problem that data teams face, and that's data sprawl. So the acceleration of AI, machine learning, and large language model usage means there are more ways in which enterprises are able to get business value out of their data. Data sprawl is occurring as data is being put in many places without protection, and this increases the risk vectors for companies. As the number of data pipelines and applications increase, companies need to implement stronger data protection measures. So remember that first diagram I showed you of what traditional data teams face? Modern data teams face significant data sprawl. So let's start with a simple use case where a team is using their Postgres database for their application, but they need a reporting replica to be able to run their analytics. This replica pushes data to reports and maybe some CSV files. It also feeds into a reporting application like Tableau, which then sends out reports to employees who then download the data into Excel. They do their own analysis, and then they email that to their coworkers. Then another project comes along where the data team wants to move some of the data into a data warehouse or a data lake. And the teams using the data lake prefer to use Power BI as their reporting tool. And maybe they're feeding some of that data into a new generative AI model, and they want to take backups of that data. Then we have another team that's only interested in data that's changed. So they set up events to stream into a cloud data store, such as an S3 bucket. Then they want to do analysis on these events. So they generate reports, which they then send out to stakeholders who download them, email them to their executive team. And then, of course, some teams just want APIs to pull data out of Postgres to build their own pipelines. They capture the data, and then they create their own Tableau reports and analytics. So most people look at data pipelines as sequential and discrete. But to me, the better image is a prism where shards of light or shards of data just expand outward a million different directions from your database. In a scenario where you thought you had one column in a database, social security number that you need to protect, you actually have to protect it in 100 to 1,000 different ways. When I think about how you protect this data coming out of this prism, implementing access controls in applications is a never-ending task. Every time you need to add a new system or an application or report or data feed or some new project comes along, you have more work you have to do to protect your data. You could use a strategy, but it makes you a lot less agile and flexible in using your data.
So Laura, this seems so complicated. What can data teams do? How can they protect their data?
Well, so let's look at some various privacy enhanced technologies that attempt to do this. But before we do that, we wanted to see what the audience's experience is with privacy enhanced technologies. So you should see a poll pop up. Have you used any privacy-enhanced technologies or confidential computing? Yes or no? Okay, we'll just give everybody a minute to answer.
So it looks like, Laura, that we've got more than half of the people have used or have experience with privacy-enhanced technologies or confidential computing.
Oh, that's a really great mix. So, you know, myself, even with my background, I didn't have a lot of experience with privacy-enhanced technologies. And so I have really very quickly come to learn about all the different options that we have. So at a quick glance, you can see that with privacy-enhanced technologies, there's really no perfect solution, and they all come with their advantages and their disadvantages. So the first one, confidential computing, is, you know, or enclaves. That's where all computing occurs in an enclave. And you can think of an enclave as a special little room that is dedicated just to be able to do computations on encrypted data. So that little room, that enclave, requires special hardware and or significant storage space, leaving you very little flexibility in designing your system and no ability to do distributed computing. There are additional costs in using this type of hardware, and there can be delays in procurement, installation, and deployment. This really prevents your business from being agile and in adapting to business events. They also don't support managed databases, so you have additional costs to self-manage your database. And lastly, your DBA always has clear text access to regulated data. So the next option is application access controls, which we were discussing a little bit in terms of data sprawl and that whole data prism. While data is protected in one application, once that data moves to another system, access control is lost. So adding more pieces to your pipelines means adding another application to protect. I think of this game as whack-a-mole, which, you know, if anybody knows about this little game that kids play, right, where you're constantly monitoring and popping up and trying to figure out where's your data and then trying to smash it down and make sure that it's protected. The last option is homomorphic encryption. So I recently wrote a blog post about this for Baffle, and the biggest drawback to homomorphic encryption is performance concerns. So you either have increased computational overhead or performance impacts every time your data is read. And that's really just essentially a non-starter today. People need good performance when they try to access data. It also requires significant storage space, which means additional costs and maintenance. And most importantly, homomorphic encryption only addresses a subset of operations depending on the type of encryption. So you actually need a variety of protections to be able to protect all of your data.
Laura, none of these seem to hit the mark. What other options should be considered?
Well, let me tell you a little bit about Baffle Advanced Encryption. So Baffle's advanced encryption is encryption that allows any and all operations on encrypted data. So how it works is Baffle's advanced encryption is a proxy-based model. Baffle customers use our security platform, Baffle Manager, to create a Postgres database SQL proxy called Baffle Shield that protects their data. So looking at this diagram, we have a Postgres database that's already protected by Baffle, where regulated columns are encrypted in the database. Baffle's advanced encryption is a set of Postgres database extensions or plugins that support any and all operations occurring on encrypted data. Baffle protects all data coming out of the data source, so reports, spreadsheets, exported data sets, SQL queries, analytics applications, everything. Only show clear text data to the users who have permission access. This is data-centric protection. Remember that whole prism diagram? We're protecting that data source, and wherever that data streams out of that prism, we are protecting it. No matter where the data flows, it's protected. You can also add role-based access controls, controlling who gets clear text access to the data. Depending on your access controls, no one may be able to see the data in clear text, even database administrators. You get to define who can see your regulated data. And with Baffle, no application changes are required, and Baffle integrates with key management systems, so you own your own keys to your data.
Laura, do you have an example of what this looks like when someone is doing analytics?
Yeah, Yeah, so let's say you have an analyst who wants to look at trends in healthcare data. So they have access to a patient database that is chock full of regulated sensitive data. For this example, I've kept it very simple. I've included a few columns like full name, date of birth, and the patient's medical conditions. And their company uses Baffle, and for their role, they're not allowed to see name, date of birth, or any medical conditions. And maybe the analyst has a very simple question, such as, with patients who have hypertension, what's their average cholesterol? What's the min cholesterol? What's the max cholesterol? Baffle's advanced encryption allows them to answer questions like this without ever having clear text access to sensitive data. Advanced encryption lets them search the data that, if you look at that SQL statement, it's the like statement. They can search within an encrypted column without actually ever seeing the data in that encrypted column. To me, this is incredibly powerful and exciting to know that we can enable data teams to still do their jobs without putting the person or the company at risk of not being compliant with privacy regulations. So in some ways, this feels like magic. And so I think it's pretty important to walk through the technical details of how Baffle is able to achieve this. We do want to kind of understand how technical the audience is. So we have another little poll to find out how much experience you have with SQL. So how much experience do you have with SQL? 0 to 1 year, 2 to 5 years, 5 to 10, 10 plus years. While everybody's choosing in their poll, little fun fact, SQL came about in the 1970s. It was added to the ANSI standard in the 1980s. So we didn't want to put out 40 years on here because then no one would have that much experience.
All right, so it looks like we have, I think it's skewed a little bit to the 5 years and less, but there are people who have 5 to 10 and 10 plus years.
Okay, yeah, 5 years to me is very experienced with SQL, which is great. So what we'll do is we can just walk through, we'll just follow a query along to understand how the database, the proxy, and the extensions work together to protect your data. So here you can see in step 1, you have your application or your report or your SQL query, whatever it is that you're running against your database, and it issues the query to the database. And then in step 2, the proxy, or the Baffle Shield as we call it, intercepts the query. It looks at whether this is a protected column and what the access control rules are. If it is a protected column, the shield will rewrite and transform the query according to the role-based access controls you have defined. And then in step 3, if you happen to use an operation that requires computation on an encrypted column, that's that like statement that we were discussing, Baffle Shield recognizes that you have used this operation, and it parses that operation and sends it to the Baffle Advanced Encryption database extension to complete. And then in step 4, that Advanced Encryption extension performs the calculations on the encrypted data, and then it sends the results back to the Baffle Shield. And then in step 5, that Baffle Shield sends the results back to the application. And then depending on your role-based access control and whoever issued that query, it will return the results either encrypted or in clear text.
So Laura, thanks for walking everyone through it, but how does this compare with the other options you showed earlier?
Yeah, so Baffle's advanced encryption has really solved the last barriers to adopting encryption for analytics. It provides data-centric protection without the use of special hardware. It supports any and all operations on encrypted data while being highly performant. And its role-based access control reduces the number of people in your organization with clear text data access, ensuring that you comply with any and all privacy regulations.
So Laura, how would you summarize the key capabilities of Baffle's advanced encryption?
So unlike other privacy-enhanced technologies, Baffle encryption is a software-based approach to confidential computing. It's a pragmatic balance between security, speed of deployment, flexibility, and cost. And unlike application-level encryption or policy-based access, Baffle's modular platform is easy to implement, ensuring no code changes to applications are required. And most importantly, it is data-centric protection, protecting data wherever it floats.
So Laura, this seems all good, but how does this fit into the larger data security program that companies need to implement?
Yeah, so Baffle also offers significant benefits to your enterprise. Baffle is an early player in the Gartner Data Security Platform, BSP category, and this platform provides enterprise benefits. Baffle protects your data at rest and in use while maintaining the utility of the data. It allows you to implement data protection policies and then also provide logs for compliance reporting. It's not enough with the regulations that exist and that are coming for you to just implement these. You need to be able to provide evidence to clients that you're doing that. And then with Baffle, you can easily enable clients compliance with privacy regulations such as GDPR, CCPA, and also meet PCI v4 requirements for credit card data. Baffle also integrates with data security posture management tools, DSPM. There's a lot of acronyms in security, and all of this together results in a proactive data security posture rather than a reactive data security posture.
So Laura, this is great. Let's see if we have any questions from the audience. So let me just check that. But before we do, if you want to learn more about advanced encryption, please go to baffle.io/technology/advanced encryption. Just go to the Baffle website, you can find it. And then if you want to see a demo of advanced encryption or try it in your environment, please go to baffle.io/request-a-demo. And again, that link is available from the Baffle homepage as well in the top right. Okay, on to your questions. So it looks like we have a few here. And the first one is, other than a data analyst, what are some other use cases for advanced encryption?
Well, yeah, there are a ton of use cases for advanced encryption. The top one that springs to mind is secure data sharing. So very often companies will want to share data so that they can leverage either information about shared customers, or in the case of healthcare, they want to be able to share patient data and patient outcomes, but they don't necessarily want to expose that regulated data. Advanced encryption allows them to be able to share data and also make sure that they are keeping both sides of the information secure, but then allow them to do analytics based on the combined data sets. Another one that's really big to me is financial and fraud analysis. The PCI v4, if you're not familiar with that regulates what needs to be done with credit card numbers. In v4, it says that transparent data encryption, TDE, is not enough for compliance. And so using Baffle's advanced encryption allows you to be compliant with PCI v4. And then, I used a very simple, very simple data analyst query from medical research. But again, if you just think about all of the incredible information that different medical research and studies have been able to collect, but are unable to actually analyze in mass quantities, advanced encryption is certainly something that I think is a very, very exciting product to be out in the market to help save lives, frankly.
Yeah, definitely. The one that you mentioned that I thought was kind of interesting was the data sharing. As companies want to share their data, they can give a summary, right, which doesn't allow further analysis, or they give their kind of raw data. But obviously, giving that in clear text means you're violating your customers and patients' PII data. So it seems that if you can encrypt it and then put in the role-based access controls that allow the analytics to happen without having clear text access to data, seems like it would be fundamental for data sharing. That's awesome. A couple more questions looks like here. It says, why is advanced encryption only for Postgres?
Well, so if we go back to that proxy-based model, unfortunately, it sounds like our audience has quite a bit of experience with SQL here. You will know that a lot of that syntax is very specific to particular databases. So we developed this first for Postgres, and so with the way that the proxy works, it really is only compatible with Postgres.
Okay. Looks like there's another question. Are there any limitations to the types of encryption you can use with advanced encryption?
So right now, in our current version of advanced encryption, we don't support format preserving encryption, FPE. So format preserving encryption is a type of encryption where it preserves the format, like it says in the name, but an example is telephone number. So telephone number in the United States is 9 digits. And then when you encrypt it, if you don't use format preserving encryption, it could be a random string of characters and numbers. Format preserving encryption allows you to have that be just a string of 9 random numbers. We don't currently support format preserving encryption with advanced encryption. However, that's on our roadmap and is expected to be coming out very soon.
Awesome. So it looks like there's some specific questions about people's environments, which will probably best to take offline. So I think that's the questions for today. Let me turn this back over to Hormaz to finish off the housekeeping.
Okay, well, thank you, Laura and Sushant. That was fantastic. I hope everybody else got as much out of it as interesting as it was. And I think a couple of quick things. We will be sending you an email with the follow-up with the link to some of our blogs, as well as the product page. And also, please feel free to request a demo if you'd like to see the product live, and we would include a link for that in the email as well. And with that, thank you everybody for joining us today, and hope you have a great day. Bye.